In this video, we are going to see about the Practicum 8 of Computer Organization and Architecture, which deals about the DMA simulation, that is Direct Memory Access Simulation. In the first program, I simulated a simple DMA transfer where memory is first initialized using the zeros function, which creates an array filled with zeros. Then random data is generated using randi function to represent the input from an IO device. Initially, the memory is displayed as empty. After that, the DMA transfer is performed by directly assigning the device data to the first few memory locations. Finally, the updated memory is displayed, showing that the data has been transferred without CPU involvement. So the second code, I demonstrate how DMA can transfer data to a specific memory location instead of starting from a beginning. The memory is initialized using zeros function and random device data is generated using randi function. A starting position is defined and the data is transferred to that location using array indexing. The output shows that only the selected portion of memory is updated while the rest remains unchanged. So the next program I deal about DMA transfer is controlled by the user. The input function is used to take the data from the user and the length function determines how much elements are entered. The memory is initialized with 0 and then the user provided data is directly copied into memory. So the output displays the updated memory reflecting exactly what the user has entered. Example, I enter 1, 2, 5, 6, 8. So same data has been entered with an array of 10 elements. So the next program is used to simulate real-time DMA transfer by introducing a delay. The memory is initialized and a random data is generated. A for loop is used to transfer data element by element, and then the pass function adds a small delay between each transfer. This makes the process appear gradual, similar to how data transfer might happen in real hardware. So the final output shows the memory after all values have been transferred. So the next code, I added a status message to show the role of DMA and CPU. The memory and device data are initialized first, then messages are displayed using DISP function to indicate that CPU is busy and DMA is started. After the transfer, another message shows DMA has completed the operation. The output includes both the messages and the updated memory, helping the visualize the process clearly. So the next program, I simulated a block transfer where data is transferred in a chunk instead of one element at a time. Memory is initialized and random data is generated. A while loop is used to copy data in blocks of fixed size using indexing. This represents how DMA can transfer large data efficiently. So in the next code, I demonstrated how DMA overrides existing memory. The memory is first filled using randi function. New device data is generated and transferred into the same memory location. The output first shows the original memory and then the updated memory clearly. So the next program, it is used to simulate transferring continuous data like a file. Memory is initialized and a fixed array is used as a device data. The data is transferred into a specific range of memory. The output shows that a continuous block of memory is updated. So the ninth program, I implemented a circular buffer using DMA. Memory is initialized and more data is generated that a memory can hold. A for loop is used along with the mod function to ensure that when the memory limit is reached, the data starts overwriting from the beginning. So the output shows the final state of memory after cyclic updates, representing continuous flow of data. So the last code, I added a counter to track the number of elements transferred. Memory and device data are initialized. For loop is used to copy data into the memory. A counter variable is incremented during each transfer. The output displays both the updated memory and the total number of elements. Give a clear idea of transfer process. Like discussed in all these 10 codes, we have simulated different DMA functions. Thank you.